Hello everyone, this is Sebastian from Risolve Studio. I'm going to go over in this video how to use the 3 different profiles that I created for RV2. And I also just want to say thank you to everybody who purchased the book. I really appreciate it and it means a lot. And I hope that you're able to get some use out of these profiles. So to start, let me just pull up where they currently are in my computer. I don't have a Mac, and I'm not really sure exactly where to install them in a Mac, but this is where I put them anyway, to use them inside of Windows. So inside of this folder, as long as you place them there, any Adobe program will be able to pull them up and use them in any of the programs. So Acrobat or Photoshop, InDesign, whatever. So once they're in here, you're good to go. And then here in Photoshop, you can see here's one of the images that I took for the book. It's flat gold, steel, aqua, and cranberry ink that's been smeared on some paper. And then I photographed it. And I photographed it into sRGB. And to view that, if you go to Edit, Convert to Profile, up at the very top, Source Space, you can see what color space that image is in currently, and sRGB. And to start, I will convert it into the faux CMYK profile that I created. Edit, Convert to Profile. I'm going to go to that faux CMYK profile, go OK. Here's all the channels for it. You can see cyan is actually aqua, magenta is cranberry, yellow is flat gold, and black is steel. So what I'm going to do is I'm going to now convert this into spot colors, into a spot color space or a multi-channel mode instead of the CMYK. So for my purposes, I don't like to keep it in this CMYK color space. I like it to be in the spot colors. So to change that is really easy. If you just go to Image, Mode, Multi-Channel, you end up with this situation. And what this is that when you go from CMYK into that sort of undefined color space of multi-channel using the spot colors, it's going to convert the different CMYK channels into what it would normally pick for cyan, magenta, yellow, and black. But I'm going to be printing this with aqua, so I just need to change this over to the equivalent of what aqua is going to be, which is 637. Right? I'll just change the name of that to aqua. Same with magenta. It's not actually magenta. I'm using cranberry, so again, equivalent for cranberry, which is 214. Yellow is flat gold. It's definitely not going to be that color. So 1245. Again, channel options, and I'm going to change this to steel, which is 302. And okay. So now if I view all those channels again, that looks like it's supposed to be. So now this is going to be all in these different spot colors in this spot color space. You can leave it in that CMYK color space with the profile that I created, but you have to embed the profile and then make sure that it is keeping that throughout your workflow process. So for example, if you bring that same image in the CMYK color space in InDesign, you need to make sure that it stays embedded when you export it out of InDesign. So, but for simplicity's sake, I think this is probably easier to do. And you only need to change this for that CMYK or that faux CMYK profile. Okay, I reverted the photograph back into how it was originally, so it's in sRGB, and I'm going to show converting it into the other 2 profiles I created. So convert to profile, I'll start with the steel, flat gold, and aqua. Perceptual, rendering intent, go OK. And if you go to the channels panel, you can see steel, flat gold, and aqua. Let me revert this back again, and I'll show the flat gold and steel profile. Okay. So now you can see that sRGB photograph is now color separated into just two Riso ink colors, steel and flat gold. As a sort of last note with these profiles is that, again, typically the profiles are created for a particular project. So screening type, paper, ink, all that stuff makes a difference in how the profile is created and how the profile works. I try to create all of these as sort of general purpose profiles, which is why if you look in the book as well, the test charts are all printed on Domtar Cougar Smooth, which for me is like a very good profiling paper. It's inexpensive and it's fairly linear, so it prints really well and is easy to measure. So again, you know, how it looks on screen to how it's going to print is still going to vary quite a bit. And these aren't all perfect right out of the box, so I would definitely go and select the different channels and make sure that you've viewed the curves and made any adjustments or corrections you might want to. So for me, I'm finding that I try to bring in some of the lighter areas on steel so that the steel doesn't show up in the highlights as much, and then maybe darken it up a little bit. You know, that's what I did anyway for the other paper that I used in the book, which was the Nina Astrobright Stardust. So let me revert this back and show the aqua, steel, and flat gold profile again. Yeah, okay, so here's the histogram for those 3 spot channels. And so again, I want to pull some of the steel out of the highlights. You can see it change a little bit in the art. I try to do like maybe 2 or 3, and then I darken it up a little bit. And that's been just about all that I needed to do, really. You know, flat gold if you need to. But again, the only thing that I really changed when printing onto that Nina paper was the steel in the highlights a little bit, and then darkening it up a little. And that was pretty much it. And that's it, all ready to go. You go to File, Save As. I'm just going to save over this existing one. You just save it as a Photoshop DCS 2.0 file. Make sure you keep the spot colors box checked here. To save, yes, okay. And then you can place that DCS 2.0 file, which is just a type of PostScript file, right into Illustrator or InDesign for type layout or whatever, anything else you want to add. If you aren't doing the Riso printing with us and you want or need grayscale separations, you can do it right out of Photoshop. If you go up here to the top and you go to split channels, you now have a grayscale separation for each one of those different 3 Riso ink colors, and you can print them however you want. A better way, in my opinion, to do it is to first place it inside of InDesign and then print to PostScript, and you can create your grayscale separations that way. And I'll just show that real quick as well. So 1 second here. All right, so I have InDesign open here. I created a 5x8 page here. If you go to File, Place, you can grab that DCS 2.0 file right here that I did in Photoshop, and you just place it right there in InDesign. If you go to the separations panel, you can view the same spot colors. You can see that they're existing on their own different spot channels here. Alright, so now I'm going to go up into File and Print. Alright, so yeah, so under the printer drop-down, you just select PostScript, PPD, Adobe PDF, and then anything you would normally set up for on any other regular printer, you just go through, here. So setup, I'm going to print it onto an 8.5 by 11 press sheet. Having it centered, marks and bleeds. I'll do all the marks. Why not? Output. You have different types of output, but just separations. This stuff doesn't matter. You can select and unview. You can select or deselect the different channels that you want to print. None of that's in CMYK, so I just unselected those. So I have steel, flat gold, and aqua right here that I will be printing. And go save. I'm going to just save it over here. PostScript file. I'm going to call it test print. Okay. Pull that up. You can see that PostScript file here. Open it. It's going to run Acrobat Distiller. And it's done. Close that. And then you have a PDF. And there you go. You have grayscale separations of all those different Riso ink colors with crop marks, all that stuff ready to print. In all the profiles that I create, I put this number followed by TAC. So in this case, 240 TAC. And that has to do with ink limits that are set as far as how much ink can be printed in any given spot. So in here, it'll be 240% maximum. If I go here over to this PDF that I pulled up, this is the test chart that's generated from the profiling software. And before the test chart gets generated, I can set specifics as to how much or what I want the TAC to be. In this case, I set it at 240. So if I go to some of these darker areas like here, you can see over in the total area coverage percentage, it's 240. Nothing in this file when printed will exceed 240%, but I'm finding that 240 seems to be about the max for Riso printing sort of faux CMYK. Most of the profiles that I create are created for specific projects, and so I'm able sometimes to get the TAC much lower to like 180, especially if the ink colors fall in line with the colors that are being used in the imagery. But this is sort of a general purpose profile that I created, and I set it at 240. So anyway, so that's that. If I go back here, the next thing that's important is the rendering intent. So I'm not going to get into saturation or absolute colorimetric because they're not really relevant for this, but perceptual and relative colorimetric are. And this is also sort of subjective. It depends on how out of gamut the image is. And when you're profiling into Riso inks, the image, especially coming from sRGB, is going to be super out of gamut, but it depends on the ink colors being used. Typically for lighter ink colors, I will do relative colorimetric because otherwise the art tends to get too washed out. And light, like it's really dull in color. If it's using a lot of darker inks, then I'll probably use perceptual. And the difference between the two is that in perceptual, all the color in the entire image gets downsized proportionately to be in gamut for the profile. As with relative colorimetric, all it does is it moves the colors that are specifically out of gamut into gamut. So you'll end up with a lot of colors in sort of the darker areas. And so that's my best explanation of it, but there's a lot of other really good YouTube videos on the difference between the two and how they work exactly. I'm also going to show something in another program here to sort of example how they're working. But before I do, I'm going to just sort of say that if you were to go over to, so this is a CMYK profile, but if I go into a multi-channel profile, like the steel and flat gold or the steel, flat gold, and aqua, and I go to, let's just say relative colorimetric, and I go OK, Adobe doesn't really know how to deal very well with this color. As far as CMYK and RGB profiles go, they're very well defined color spaces, and Adobe does a really good job of displaying how that image would look printed or displayed. But when it comes to these multi-channel profiles that are sort of existing in unusual color spaces around spot colors, it's sort of doing its best guess to show you how these inks are going to interact with one another. So another program that I use to sort of help me visualize it a little bit better is ColorThink. And so I already have some worksheets that I created here pulled up so you can see the translation from sRGB into these profiles. And you can see here, this is the original image in sRGB, and with a perceptual rendering intent, it's converted into my faux CMYK profile that I created. And this is going to be probably the best rendering intent for the profile with these inks specifically. Another way to view it is if I go to relative colorimetric, it'll take a second, and then it'll show how it will look if it's with that rendering intent. And you can see it's much darker now. So like I said, if this was like fluorescent pink, yellow, blue, and black, I would probably use relative colorimetric, but with these colors, I think perceptual is much better. If I go over here into the graph, this whole area in here that you see is a lab color space, and the idea is that this is all the color that the human eye can see. If I open sRGB, you can see that this is all the color achievable with that profile. So this would be your computer monitor, cameras, things like that of a digital nature usually. So let me unview that, and then let me open the faux CMYK one that I created. You can see it's much smaller. And then also let me do another CMYK profile here. So this is sort of a very common CMYK profile that's used typically. Let me just change some of this up so that it makes a little more sense. Okay, so you can see that there are certain areas of the profile that I created, especially with this aqua ink, that are superior to one of these more generic CMYK profiles, and that just means that you're able to achieve more of this color that CMYK profile wouldn't be able to create. But most of the color achievable is well within normal CMYK realm. Just gonna unview these. Okay, so if I go back to that worksheet, I'm going to graph some of this. So I'm just going to pick random points to select of color in the image. And down below here, you can see those same points and how they are converted. So RGB, lab, and CMYK. And what I'm going to do is I'm going to graph those points. You can see these are the different points in that image. If I review my faux CMYK profile and I sort of make it transparent, you can see that all that color is really maxed out right to the edges of that color space. So the profile did a pretty decent job in being able to utilize as much color as possible. Something else that I can view here is if I go back to that worksheet and I'm going to graph this right here. Sorry if I'm going pretty slow here. So those are the same points, but in the RGB color space. So it's a much bigger area. Again, I'll just view the faux CMYK one that I created. So you can see all that color that's definitely way outside of the realm of what's going to be able to be printed in those 4 Riso ink colors. So let me unview this guy here, and then what I'm going to do is show you what happens with that color from that image when you convert it. So if I go into, let's see here, vectors, and I'm going to convert basically those points of color into the faux CMYK profile. All these lines show where the color was in RGB and where it ended up in my faux CMYK profile. So you can see this is quite a lot of shifting of the color. I'm going to view the faux CMYK profile one more time, make it a little more opaque. So you can see in the original sRGB photo, the different points of color were existing at the far end of these lines, and when it got converted, you could see where the color ended up. So it's quite a bit of a loss of color. Okay, so again, that's what this is. So it's viewing sRGB and then into how this will more or less look printed in aqua, cranberry, flat gold, and steel using a perceptual rendering intent. And as I said before, the rendering intent is up to you and kind of how you're planning on using it. And since I'm already in here, here is the same photo, but this time it's profiled into the steel, flat gold, and aqua profile that I created. And I would also use probably a perceptual rendering intent for this one as well. So you can see right there the translation. If I go to relative color metric, it's going to be much darker. Yeah, so, you know, just something to experiment with. And that pretty much summarizes my video. This probably didn't need to be that long, but I hope that I included as much information as possible that was useful. And yeah, so thanks again for watching, and thanks again everybody who bought my book. Again, I really appreciate it, and it means a lot to me. So yeah, that's it.